there, so welcome again to another episode for a new math lesson that we are going to have for this day. In this video, we're going to learn about something that will help us simplify expressions further and that will surely help us solve math problems easier, and that is through the two of the laws of exponents that we are going to tackle about, which are known as the product rule and the quotient rule. Now for this one, let's consider the following example. Let's have first 5 squared times 5 cubed. Now to simplify this one, let's observe its expanded form. For 5 squared, that is the same as 5 times 5. And notice that we are to multiply this one to 5 cubed. So I will multiply this one to the expanded form of 5 cubed. And that is 5 times 5 times 5. Now notice that the factors are the same here. So we can just simply rewrite this one as 5 raised to 5 since we now have 5 copies of 5. Now let's have another one. Let's say we have 2 cubed times 2 raised to 4. 2 cubed is the same as 2 times 2 times 2. And multiply it to 2 raised to 4, which is the same as 2 times 2 times 2 times 2. Or simply, this one can be written as 2 raised to 7 since we use 2 7 times as a factor. For the last one, we have m squared times m. M squared is the same as m times m, and we are to multiply it again with another m. Now, we used here 3 m's as a factor, so this one can be simplified as m cubed. Now, try to observe the relationship of the exponents in the given expressions to the exponent of our final answer. Exponent of the given expression to the final answer. So this one is 1, and we have 3. Now if you will notice, the exponent in our simplified form or final answer is just the sum of the exponent in the given expression. So 2 plus 3 is 5. 3 plus 4 is 7. 2 plus 1 is 3. Now, actually, that's the idea of what we so-called the product rule. Now, let's try to apply if that idea of product rule that we have in mind is correct with this example. Let's say, for example, we have this one. A squared b times a b squared. Now, a squared b in expanded form is the same as a times b. And we are to multiply it to ab squared, which is the same as a times b times b. Now, let us simplify this one through our idea about exponents. Now, since we used here a 3 times as a factor, so we can just simply write this one as a cubed. While for b, again, we used it also 3 times, so we have here b cubed. Now, let's see if our idea of adding the exponent is true for this example. Now, in the given, a is raised to 2 here, and the other one, it's raised to 1. Now, 2 plus 1 is 3. Now, for b, the powers are 1 and 2, and the sum of 1 and 2 is also 3. Now, therefore, that idea of getting the sum of the exponents of the same base is true for any case. That summarizes what we so-called the product rule. In general, the product rule states that when we are multiplying expressions with the same base, we just simply copy the common base and then raise it to the sum of the exponents of the given expressions. Now this time, let's try to find out how and when to apply the quotient rule through the following examples. Now let us consider the following examples. Let's say we have x raised to 4 over x raised to 2. Again, we'll work on its expanded forms. So for x raised to 4, that is the same as x times x times x times x. While for x raised to 2, that is the same as x times x. Now, how can we simplify this one? So we will get the idea that when we are dividing and the divisor and dividend are the same with each other, or are of the same values, that will result to 1. Let's say, for example, 2 divided by 2 or 2 over 2, that is equal to 1. Another one, 3 divided by 3 or 3 over 3, that is also equal to 1. So as long as the numerator and the denominator or the dividend and divisor are the same, that will always yield to 1. So in general, whenever the numerator and the denominator are the same, so technically that will give us 1. Now we will have that idea in order to simplify this expression. For this one, so I will take this pair x over x since that is equal to 1. I will also take out this one since that is also equal to 1. Now what will be left in my expression now is just simply x raised to 2 since I have here 2x over, since it's already 1 and 1, so over 1 or simply x squared. Let's have another one. Let's say we have n raised to 5 over n squared. N raised to 5 is the same as n times n times n times n times n. While n squared is the same as n times n. Now again, I will cancel out pair of numerator and denominator that is the same. Since that is equal to 1, so this one is equal to 1. Also, this one is equal to 1. Now, what was left in my expression is just simply n raised to 3. Okay, another one. Let's have a cube b squared over ab. Now, expanding these expressions, for the numerator, this is the same as a times a times a times b times b for b squared. And for the denominator, that is just simply a times b. Now again, we will cancel out pair of numerator and denominator, which is the same since that is equal to 1. Like this one. A over A, that is equal to 1. B over B, that is also equal to 1. Now, what was left in our expression is just simply A squared B, or A squared times B. Now, try to observe again what happens to the new exponent that we have to the exponents of the given expressions that we are dividing. Now, notice 4 and 2, and it result to 2. 5 and 2, it result to 3. 3 and 1, it result to 2. 2 and 1 for this, it result to 1. Now, if you will notice, these are just the difference of the exponents in the base of the numerator and the base of the denominator. So, in the first one, the exponent of the base in the numerator is 4, and the exponent of the base in the denominator is 2. So, 4 minus 2 is 2. 5 minus 2 for the second example will give us 3. 3 minus 1 for A, that will give us 2. 2 minus 1, that will give us 1. So that is the main idea of the quotient rule. We are just simply getting the difference or subtracting the exponents of the bases in the numerator and in the denominator. Now, it's easy for us to understand if the exponent of the numerator is greater than the exponent of the denominator. Now, what if we are given an expression wherein the exponent of the denominator is the one greater than the exponent in the numerator? Let's find out if the quotient rule also applies to this one. So let's have an example. Let's say we are given this one, x raised to 3 over x raised to 5. Now, expanding this, we will have x times x times x, while for the denominator, we will have x times x times x times x and times x. Now, again, we are to cancel out pair of numerator and denominator which are the same because that is equal to 1. So, cancel this one, cancel, and cancel. What was left in our expression is just simply, since this is just 1 times 1 times 1, so simply 1 for the numerator, and we have here x squared. Now, let's try to apply the idea that we had a while ago that we are simply subtracting the exponent. So, given x cubed minus divided by given x cubed divided by x raised to 5. So, we said a while ago that we are just simply subtracting the exponent of the numerator to the exponent of the denominator. So, that will give us 3 minus 5. And 3 minus 5 is the same as negative 2. Now, try to observe the answers that we obtained a while ago. How can we relate x 1 over x squared and x raised to negative 2? Now, looking back at our previous discussion on exponents, these two are just actually equal based on our idea about negative exponents. Can you follow? So, therefore, our idea about subtracting the exponents of the base in the numerator and the denominator is true for any case. And that is the rule for the quotient rule. To summarize, the quotient rule states that whenever we are dividing expressions with the same base, we just simply copy the common base, then subtract the exponent of the base in the numerator part by the exponent of the base in the denominator part, like this one. Now, let's try to apply what we have learned about the quotient rule and the product rule through this example. Now, you have two ways to answer this. You can first have the product rule or the quotient rule first. So, if you wish to do the quotient rule first, so you need to simplify each expression first. But if you prefer product rule, you can multiply the numerator to numerator and denominator to denominator. Now, let's try to use the product rule first. So, we will have in the numerator to the numerator, I will have x raised to 5 times x times y raised to 2 times y raised to 2, then times c raised to 3 times c raised to 2. This is for the numerator, while for the denominator, let's put all together the common bases. So we will have x raised to 6 times x times y raised to 3 times y, and then times c raised to 2 times c raised to 3. Now let's now simplify the numerator and the denominator. Now for x, since this is 5 and this is 1, so 5 plus 1, that will give us 6. So x raised to 6. While for y raised to 2 times y raised to 2, that will give us y raised to 4. No need to put the multiplication symbol here. So it's understood that the operation in between the two variables is multiplication. While for c, we have 3 plus 2, that will give us 5. And for the denominator, we will have 6 plus 1, that will give us 7. Y cubed times y raised to 1, that will give us y raised to 4. And for the last one, z raised to 2 times z raised to 3, that will give us z raised to 5. Now, to simplify this further, let's now apply the quotient rule since we are now dividing the numerator by the denominator. So, we will have x raised to 6 minus 7, since we are to subtract the exponent of the numerator by the denominator. For y, we will have y raised to 4 and then minus 4. And then for c, we will have 5 minus 5. Now for 6 minus 7, that is negative 1. So we'll have x raised to negative 1. For y raised to 4 minus 4. So y will now be raised to 0. 5 minus 5, that will give us 0 again. So we'll have c raised to 0. So in short, our final answer now will be x raised to negative 1, which is the same as 1 over x. So this one is our final answer. So why not include this 2, since this 2 is just equal to 1, since both of them are raised to 0. So this one now is our final answer. So that will be all for our discussion about the product rule and the quotient rule. I hope you learned something from this video. See you again to another episode of a new math lesson. Thank you for watching.